Hello, this is Ken Fast from Electric Boat. Thank you for joining us for our talk about AR and defense shipbuilding. Electric Boat is a large shipbuilder. We're located in Connecticut and Rhode Island. We build nuclear submarines for the US Navy, and we've been in operation for over 120 years. And you may hear me call it EB as opposed to Electric Boat. That's what the locals here call it. And Dave, I'm joined by Dave Heath.
I'm Dave Heath. I'm from Bath Iron Works. We're as well a large shipbuilder. We are located in Bath, Maine. We build large surface combatants for the U.S. Navy, and we've been building ships for over 130 years. And back to you, Ken.
Okay, and both Bath Iron Works and Electric Boat are part of General Dynamics, a large defense contractor. And Dave and I have known each other and worked together for about 25 years now. So we're going to do a little collaboration. So we want to talk to you today about augmented reality and using augmented reality to in our shipyards for doing real work. So it's not about technology. Now we love technology. We're geeky guys and we love new technology, new things, but it's not about the gadgets. It's about actually getting something done. So we're trying to get real work done in the shipyard, building things, and we're going to use augmented reality to do that. So just a little history at Electric Boat. We have a long history of using technology to do real work. Back 25 years ago or so, we transitioned from using a wooden mock-up of the design to going to all digital for design review. So this was a virtual reality application that actually did real work. It was high tech, but it was really focused on doing real work. And similar things happened at BIW.
Yeah, from designing and engineering ships on paper for decades, coming into the mid 80s, late 80s, early 90s, we got into computer automated design, started creating 3D content. In the early 90s, BIW started using visualization tools on Silicon Graphics computers, worked with Computer Vision CADS 5, CATIA AutoCAD, and we built out this huge core of 3D data that we can now utilize in more recent display tech such as VR and AR.
Okay, so as shipyards, there are some complications to doing technology work. So that the shipyard is, we build metal boats. We're not high-tech companies. We're not in Silicon Valley. We're in the gritty Northeast, and we have limited research and development budgets, limited technology culture, and as defense contractors, everything's always complicated, restrictions on hardware and software and doing work that's outside of the box. So everything's a little bit complicated.
Very true. It's super difficult to take it to the next level often because you have so many things, so many wickets that you have to go through, so many levels of you have to go through to get your project accomplished.
So the keys to implementation here, keys to getting things done, and of course it's never as simple as it sounds, but R&D resources, you really need to take advantage of anything that's available, internal, external funding for things. We've even done work on our own, nights and weekends, things, learning about new technology or experimenting. With projects, you need to start small, find one thing, find a real solution to a real problem and show that it works. And that gets people excited. We work directly with the end users, the mechanics out on the shop floor. If they get excited about something and agree that it actually works, it's a real boost to getting things done. It's helpful to get upper management interested in what you're doing too, but working from the ground up seems to be really useful with the small to large as it grows. There's a lot of demos involved, a lot of internal advertising, right? So you start with a simple project and you show it again and again and again to different people until, sort of shopping out till you find an interested management customer or a funding customer. And another thing is this find your own strength. It's, R&D work is, although it's technical, it's also, there's a certain personality, emotional content to it. And you need to figure out where you fit in the big picture. So for me, it's getting practical little things to work. I can make things work. That's what I do. So I'll make little tools, little demos that actually work. They do something, and get those out in front of people to see them. Dave's got different skills. Dave, you want to mention something?
Yeah, I have years and years of graphical, like animation, working on 3D Studio Max and things like that. And like where Ken had said, starting small and working with a limited budget that you have, often you want to build out something to explain the concept that you come up with. And that's where, if you have graphic skills, those come into play and are really good to have, because you can make little infomercials and you can make simple animations and graphics to describe that the idea that you have to others without spending a lot of money. So if you have graphic skills and you're in this realm, you will definitely be using them. That's for sure.
Yeah. Okay, so we have a couple of AR examples. These are tools that we've put into actual production, so they're being used to do real work in our shipyards. And not all of what we've done over the years, but a couple of practical examples. And we'll start with Infotagger from Bath Iron Works.
Yeah, we're going to play a video here. And all right, excellent. So what we're looking at right here is the Infotagger application. And basically, in our liaison work group, they want the ability to be able to go out and check a ship at certain points in the production cycle. So what you're seeing here in the application is one of the liaison users. There's a purple rubber band that's joined from the actual device to a tag that she's laid down, an augmented tag. And that purple rubber band guides her right to the tag. And then she can click on that tag in the AR display, and it will bring up a menu where she has a time, date, stamp blog. She can add audio notes, and she can add a bunch of other information and an image gallery, and records that and then lays that down into a database, and then that can be shared with anybody else with a device.
Okay.
So currently we're using this application in production, and we're excited about where it's going to go from here.
All right. So we have another example from Electric Boat. We're using AR to do electrical hanger installation. The picture on the right here, you'll see things sticking down from what looks like a ceiling. There's threaded studs that get welded on the structure early and then painted over. And we install things get bolted onto those. They're threaded like bolts, so we bolt things on. But when you go to install, you're going back to a 2D drawing, essentially, like the image on the left, trying to measure in 3 directions to figure out which piece goes on which studs. So we've come up with an application where we can overlay the CAD geometry right on top of the work surface, so we see where things go without having to measure. And the studs are already there, so we have a point of reference. And I apologize if you've seen this picture before. I've shown this in a lot of places because I have a limited number of pictures that are approved for public release. So I'm reuse, recycle. I've got a little video clip here that shows what this looks like on the screen. So again, I apologize. This is not the interior of a ship, but the ceiling of an office. But this is it is a screen scrape from the application. So as the user walks around, they see CAD geometry drawn into the world. And we've come up with a method to register the device to its location in the real world, so the CAD geometry shows up in the correct place as you walk around. So this is real CAD geometry showing up in the real world. Okay. So then another example, this is the same type of application here, a little bit different setting. We've got, you can see our device here. These are Tango devices. The yellow 3D printed cases, courtesy of Dave's group at Bath Iron Works. So they made these up for us. And here they're doing an inspection task. The video shows as the user moves around, they see actual hangars. They're overlaid by virtual hangars with labels, and they can verify that the labels have been correctly placed before they go to install wiring. Again, the device has been registered to the area, and what shows up is CAD data directly from the product model, and it shows up overlaid on top of the real world, matched to the location. So this might not seem like it's a pretty simple task. You're just installing things on bolts that are there and knowing what's there. But the use of augmented reality has been very successful in reducing installation time and improving quality because we've eliminated some errors. The composite numbers show that we're saving about 12 minutes per part that gets installed. And considering that just with these electrical hangers, there's tens of thousands of these. So it becomes a huge sum when you add it all up. And it will work for other activities as well. So we're exploring. But today, we saved thousands of production hours using this tool in the shipyard. Okay, so a couple simple applications. There's a little more to it in real life, of course, than what you see on the screen. It looks easy when somebody else does it, but you know, we wish we could give you all the secrets for getting this to work in your production setting, but it's probably a little different in each company. It will be hard. It will be resisted because it's different than the way you normally do business, and it will take a long time. You should expect all of those things. But if you can come up with a new technology, a practical solution that solves a real problem, you could become a company hero.
Yeah, and just be patient and never ever give up. That's for sure.
Okay, short and sweet. Thanks for listening, and we'd be happy now to entertain any questions.
Hey guys, nice to meet you. Great presentation. Was really exciting to see all the great results that you guys are getting, and also we've had basically been behind all day, so this is my first time really being able to catch up and dive into some Q&A. So exciting. So we have a handful of questions coming through. I think we'll just get started with Julia B. She asks, what are you using for your physical location tracking within a ship structure?
Well, we're using Tango devices right now, which have built-in motion tracking. And so you do an initial registration, you find a known location and get the device into a known location. There's a little bit of magic there. And once the device knows where it is once, then the device is able to track locally just using its own internal tracking.
For InfoTagger, we're using ARKit on iOS devices. And basically, it's not important to put it into the ship's coordinate system. What we're doing is saving maps, and those maps are saved off to the network, and then you share that map out to another device, and then they call that map up, move the device around, and it recognizes the point cloud cluster and then reorients that set of info tags to that space.
Awesome. And then Nadine is actually asking where they might be able to find more information, if anywhere, around the info tagger. because she has a potentially relevant application for that. So maybe this would be a good opportunity to point to some more information on the info tagger, and then provide any ways of maybe getting in touch with some of the people listening today.
Well, we can't give you our code, but Neil Matthew from a company called PlaceNote has something that's very similar. And I would recommend look up PlaceNote on the internet and you'll get pretty close to it.
If you do contact us, the info tagger code was written by another General Dynamics group, and they actually might be interested in reselling that. So our contact information should be in the AWE list somewhere.
Awesome. And then we got a question from Kerwin, and he's asking, what did you find to be one of your biggest challenges with the implementation of your AR applications?
Wow, that's a big one. I'll answer it from the Bath Iron Works side. It's adoption. It's getting production. That's one. I'd say adoption, getting past the security wickets, getting a device to communicate with the internal network. For me, those are the big ones.
Yeah, for us, the development cycle with Android was kind of a new thing for us. So most of our work has been C++ on bigger machines. So there was a certain learning curve with getting Android stuff and Tango stuff as well, which was once you know how to do it, it's really easy to use, but the documentation wasn't always exactly adequate. But and then finding the right application. So the tracking with AR today is not exactly precise. So you need to find things where you don't need sub-millimeter accuracy over a big area. It's a localization and reference tool, and there's a lot of applications for that. So it's really useful for those things. You got to find the things that it's useful for. So.
Great. And Devin has a good question that I was actually curious as well. I had got, my past in AR was creating head-worn glasses, and we did a lot of work with different government agencies, including the Navy. And this was a big one we always ran up against. And Devin's question is, do you have high-quality Wi-Fi available at the ship sites? And I guess the bigger question is, how do you manage Wi-Fi and devices on these sites?
Well, at Bath Iron Works, if you put enough repeaters anywhere, you'll get a good Wi-Fi. So we've been operating with a pretty decent Wi-Fi. I think Electric Boat is a little bit more limited in that, but I'll let Ken speak to that.
Yeah, we don't have, we do have Wi-Fi coverage these days in a lot of our production areas, but actually our application is all self-contained. So you really can load all your data ahead of time and just go out to the site with data, because you're not carrying the entire product model. You're just carrying the parts that you're going to install. So it's not really that much data. So we don't need a live connection for what we're doing. It would be helpful downstream, but.
Awesome. Well, kind of piggybacking off of that question, I think the other thing that obviously always popped up for us were the security requirements. So how do you manage, implementing new immersive technology, new devices in these secure environments? What are some of the ways that you may have been able to try to overcome some of those tough challenges that you guys have?
Yeah, for us, we don't have that many devices out in production, so we can manage them because we know where they are, and there aren't that many of them, and they're important. So we track them physically. We know where they are, and sign in, sign out kind of a thing. So
yeah, from a Bath Iron Works standpoint, the whole idea that it's called security means we can't talk about it,
As far as, managing your devices, you have to have a good MDM, and then you have to have a fairly decent network. And
Right.
if you have those two things in place, then you're going to be doing fine.
Yeah, in the future, we're hoping to move to
All right.
Windows devices on our network anyway. So,
Okay.
so then there's no security risk because they are regular network devices that are approved for use. So.
Awesome. Well, Ken, David, we're out of time, but thank you so much for that presentation. I know I saw the questions going crazy on it, so I know everyone was engaged. And if there's a few questions I missed, I apologize. But maybe if you guys have a few minutes, you could answer some of the audience's questions after the event. So thank you again, and have a good rest of the day.
All right. Thanks for